right, this lab is going to go over, name that precipitate lab. So what we're going to do is first record our observations. I have here my aqueous solutions, which means that the ionic compound has been dissolved in water. So I'm going to go ahead and get my Na2CO3, and I go ahead and add 1 drop in each cell going down. Do the same thing with Na2SO4. Next I have NaOH. And then I have Na3PO4. And then now what I'm going to do is I'm going to go ahead and add the chemicals going across. So I have lead 2 nitrate, now I have calcium chloride, not a full drop fell there, so I just add a little bit more. And the last one, AgNO3. No, it didn't quite fall in. There we go. Okay. Now it says remove the white sheet. So that's what I'm going to do is remove the white sheet and let the chemicals mix. So here you can see that I have reactions in all of these, and these, but these two do not have a reaction, and the reason why is because there's been no change in there. To let the chemicals react and then record observations about each precipitate. If a precipitate is formed, write PPT in the data table. Also include the color and any other descriptive term. Whether it's milky, grainy, cloudy, or gelatinous, you must also include the color and another descriptive term. If no precipitate forms, write NR. So for my reaction here, right, I'm definitely going to put PPT for all 3 here. And I'm going to fold my paper just so that you can see everything at once. And then here, the next column, I have a reaction, no reaction, no reaction. So here I'm going to write PPT, NR, NR. Over here, I'm going to go ahead and record that there are reactions in all these and all these. So PPT, 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 PPT. And remember, PPT, according to our pre-lab, means that a precipitate formed. So that is when a solid forms, and it's because 2 aqueous solutions have combined, right? But a solid forms, and you can see the solid sheet. So now I would definitely say that these are all white. All these are white, 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 but this one's yellow. So we're going to go ahead now and record the colors. No reaction for these. And then now the directions say that we need one other descriptive term. So milky, grainy, cloudy, or gelatinous. I want to help you with the first one, and then I'm going to let you do the others. Okay? So here, right, I can definitely say that this one is, I shake it a little so that we can see, right, if the particles are able to move on the inside. And like here, the particles aren't really moving. Like this one they are, but this one's not. You see that? So I would say that these two are gelatinous, right? Because they're almost like a gel. They're very, or they're thicker. They have a more viscosity compared to like this one. This one here, you could term technically cloudy. But then when I look closer at this one looks grainy, whereas this one still looks gelatinous, cloudy, grainy. So I'm going to help you with these. This one we said is gelatinous because it's like a gel staying together. This one's cloudy, and this one's grainy. So now what I want you to do is give me another descriptive term for this one. You don't need them for these. So let's see this one here. So I'm going to zoom in for you so you can see this one. So it's kind of staying together, right? So go ahead and record your observation, your third observation for Na2SO4 with lead 2 nitrate. And then now what you're going to do is record another term for these three. So I'm going to go ahead and zoom in so you can see these. So I'm going to shake it a little so that you can see what they look like. Zoom in a little. So you can go ahead and give a third descriptive term for these three. If you need to see it again, I'm going to zoom in. And then now we're on the last column. So now we're looking at these three. And I want you to go ahead and add a third term. So you can kind of see how this one's kind of staying together. I can definitely see little grainy particles in that one. Okay, this one, it almost just looks like a film, like a cloud. All right. When it comes to these descriptive terms, right, what I'm looking for is, do you have three things or no reaction? No reaction just has one thing. So you should have, right, added another descriptive term here to these and to these. If you need to go back and look at the video, that's what you want to do. And now we're going to look at the back. So it says, determine the chemical formulas and names of the newly formed compounds using the ionic charges. You will combine the cations from the cells that are in bold. We want the cations from the cells that are in bold. So the cation would be the positive ion. So that's the first one, right? And then the anion from the cells in gray. So I'm going to go ahead and look at those. And I'll need my periodic table and my polyatomic ion sheet. But I'm going to highlight my anions. Okay. So now I'm looking at my periodic table and my ion sheet if I don't know them, right? So here I have my lead. And so I'm going to record that the name of that is lead. But if I look at lead on the periodic table, it can be 2+ or 4+. So which one is it? Well, I know that this is nitrate. So if I go ahead and try to figure out what is the charge of the PB? It must be this one. So this is PB2 plus. And because it can have more than one charge, it's going to be lead Roman numeral 2. Now, you cannot get prefix or Roman numeral happy, because what's going to happen with this one, right? I know that this is Ca, which is over here. This one only has one charge, so don't put Roman numerals on this one because you only have one charge here. So don't start putting Roman numerals on everything. It just depends, right? If the metal has more than one charge. But also look at Ag. I can see that that one also has one charge, so it's not going to have a Roman numeral. Now we look at the anions. The anions, right, are all polyatomics. And so if I don't know my polyatomics, I'm going to look at my sheet. I know this is carbonate. So this is CO3, 2 minus, name is carbonate. So what I have to do now is combine the cation and the anion. Remember, the cation, the positive ion, goes first. So I'm going to combine these two, Pb2 plus, CO3, 2 minus. I know from chapter 7, right? Because this is a lab from chapter 7. These are what I would highlight, and then I go ahead, rewrite everything that isn't highlighted or a charge, leave a little space. 2 plus 2 minus cancel, so that is my formula. And the name of this, right, would be the first part of the name, cation, then the anion, so it'd be lead, Roman numeral 2, carbonate. Now it says you do not need to determine the names or formulas of the ones that did not have a reaction. So everyone should be crossing out this one and this one, because in the lab we did not have a reaction for this one or this one, which corresponds to these two cells on this lab. So what do you need to do? You need to finish the name and ions here, and then go ahead and fill in the formula and names of these.